All right, this is Calc AB Notes 3, page 2, kind of like part 2, I think. We talked in the last video about a lot of things. So we talked about if you're moving horizontally, positive velocity means right, negative means left. If you're moving vertically, positive means up, negative means down. Then we talked about speed. Speed is the absolute value of velocity. Can't stress that enough. Just the absolute value of velocity. Somebody asks you about the speed, just take the absolute value of the velocity. You're done. We talked about when speed will be increasing or decreasing. Speed will be increasing when velocity and acceleration have the same sign. Speed will be decreasing when velocity and acceleration have opposite signs. That's actually all you need to know. You need to know the sign of velocity, the sign of acceleration. If you know both of those, you know if the speed is increasing or decreasing. So remember, speed, absolute value of velocity. All right, now what we want to do here is kind of combine this to describe motion. So for example, if v of t is positive, so basically we want to say, let's assume that we're moving on a horizontal axis. So, which I would say is probably like the most common. If you're moving vertically, then just change every time I say right, change it to up. Every time I say left, change it to down. And that'll deal with the vertical axis. So if v of t is positive, so we don't care what a of t is. If v of t is positive, you are moving right. Okay, now we want to talk about the speed. Is the speed increasing or decreasing? All we need to know is, do velocity and acceleration have the same sign? Do they have opposite signs? So since in this cell, they have the same sign, I'm going to say speed increasing. And that's it. You're moving to the right, speed is increasing. If v of t is positive, you are moving to the right. If v of t is positive and a of t is negative, that means speed is decreasing. And that's what we're going to say. Speed decreasing. If v of t is positive and a of t is 0, then you're moving to the right and you have a constant speed. So the speed is not changing. That's all we need to say on that. I mean, this is not a hard concept. You just gotta like get used to it. And once you get used to it, I don't see a lot of people getting these questions wrong. Really what I see people get wrong is when they take the derivative, like they'll get the derivative wrong and then everything is kind of wrong based on that. But if you've never seen it, you gotta see it at some point, right? So if v of t is less than 0, you are definitely moving to the left. So actually, I'm just gonna fill in. You're moving to the left, you're moving to the left. Now, if v of t is negative, but a of t is positive, speed is actually decreasing. So speed decreasing. So we're just looking to see, do a of t and v of t have the same sign, in which case speed is increasing? Do they have opposite signs, in which case speed is decreasing? So in this case, v of t negative, a of t positive, speed is decreasing. Here, v of t is negative, a of t is negative, speed is increasing. So I always think, I don't think you're allowed to call them this anymore. Well, maybe you are. Well, here, if a of t is 0, then speed is constant. It's really annoying that I wrote constant speed the first time and then speed constant the second time, but what are you going to do? This always reminds me of, when I used to play basketball or tennis, we would do drills. We called them suicides. I can't believe you still call them that, but maybe you do. So when you're doing that, you would have this line, the court, and you would start here, and then you'd have to like run and touch this, then you'd run back, then you'd run and touch this, then you run all the way back, then you'd run and touch this, and then like here. So let's say that's what we had. So when you do it, just like I always like when I try to decide what's happening with something moving along, like a particle moving along an axis, I always think of this drill, right? So you start here, and you're gonna run, and you want to speed up, but you got to like touch this, so you're gonna slow down a little. You touch this, then you're gonna run back. So you want to speed up to get there as fast as you can, but to touch the line, you got to slow down. Then you're gonna double back. You got to slow down to touch the line. Then you're gonna try to speed up so that you can get here as fast as possible, but you have to slow down to touch the line. So this is what I think of in my mind when I think of this kind of motion, right? So you start, you go boom, boom. If you actually could model what's happening with this laser pointer, it's called a laser pointer. It's not a laser, obviously. You'd be seeing all of this motion take place other than acceleration equals 0. if I'm doing the drill, I'm trying never to have my acceleration be 0. All right, so V of t equals 0, and then this row is the worst row. You'll never really be asked to interpret this in a calculus class. And I don't even know like what I like to say really. I've never like settled on anything here. If V of t is 0 and A of t is positive, so in my mind, that's like here, I'm standing here ready to start the drill, and I know that I'm gonna go to the right. So it's like I'm just like raring to go, you know? So you're not moving, so you're stopped. You're stationary, but you're gonna go to the right. So I don't know how to say that. You like want to go right, right? Your speed is wants to increase. So this like don't worry about this row. If v of t is 0 and a of t is negative, it's like you're you ran here and then you stop for a second, right? So now you're here, but you know you got to go back, right? It's like you're ready to go left. So you're stopped, you're going to go left. I don't like this row. I should have taken it out before I made the video. However, if they are both totally 0, you're just stopped. I don't even know if this is possible. Like in a vacuum, maybe. It's like you have no gravity working on you, nothing. Just velocity and acceleration are 0. Crazy. All right. So this row is unimportant. I mean, the two really important rows are these two rows. What color should I go with? Like these are your important rows. You got to know everything that's in here. That last row is kind of just think about it type of row. We don't really need it in calculus. I'm sure it's important elsewhere, but I'm not really sure about that. Okay, so a huge idea that you have to deal with: distance traveled versus displacement. Okay, distance traveled versus displacement. I think the easiest way to think about this is, let us say that you were born in a particular hospital, right? And you get taken home, so you traveled some distance. You go around, you grow up, you go to school, you do all this stuff, right? Then eventually, I don't know, you grow up, you're gonna have a kid. Turns out that kid's gonna be born in the exact same hospital room, and you go to the birth, right? When you step into the room where you were born, your overall displacement in life is 0. You basically haven't moved, right? Displacement is how far you are from where you started. So if you start in a particular room, move all over the place in life, go back to that room, now your displacement is 0. The difference between where you started and where you are currently positioned is 0. It's crazy. Distance traveled, on the other hand, is the sum total of every distance that you've ever gone, right? So these are two very different concepts, right? If you park a car in a garage and then you get your car out, you drive to work, you do whatever you do, drive to the mall. I don't know where people drive. You're traveling distance. But when you get home and you put your car back in the garage, your displacement is 0. Your distance traveled is huge. There's a really famous scene in Ferris Bueller's Day Off where they've borrowed someone's car all day and they drive it around, and then they get back and they realize, like, oh my god, like the trip odometer or the odometer is showing all the miles that they've gone, and they're like, oh, let's just like put the car in reverse and we'll run it. And they think that that's going to get the number back down. It doesn't work that way, right? They're confusing distance traveled with displacement. Not the case. Also, pretty good movie. I haven't watched it in a long time. I don't know how it holds up, but if you decide to watch it, let me know. So distance traveled is the sum of the distances traveled on each subinterval without a change of direction. So we're going to do it. Hold on here. I seem to have lost my connection. Let me see. Okay, there we go. So can I even erase? So I just highlighted this, but I'll do it again. Okay, so distance traveled, the sum of all the distances that you've traveled. So it's the sum of all the distances traveled without a change of direction, which means like You know, you were going to the left, how far did you go? Now you're going to the right, how far did you go in that thing? Now add those up. Like 3 feet to the left is just 3. And then 5 feet to the right is just 5. And 3 plus 5 is 8. So that's distance traveled. Displacement on a time interval is actually a little different. Displacement is literally just where you stop minus where you start. So let me draw something to kind of show you how this is working. So this displacement is just this. Displacement's way easier to find. That's like the one thing to kind of keep in mind. So let's say that we have a number line, and let's say that this is like 0, 6, and 10. I don't know why, right? So here, we're here at t equals 0. We're here at t equals 1. And we're here at t equals 2. Okay, so what did you do? So from 0 to 1, you went this way, right? But how far did you go? You went 6. So this is 6. And now from t equals 1 to t equals 2, you go from 0 all the way to 10, right? So this is 10. So your distance that you have traveled, so for this example, your distance is 6 plus 10, or 16. Your displacement, though, is the difference between where you started and where you stopped. You started at 6 and you stopped at 10. Your displacement is 4, positive 4. Displacements can be positive or negative, right? So for this particular, when we started at t equals 0, we were at 6, and at t equals 1, we're at 0. Your displacement is negative 6, because you are now 6 units to the left of where you started. The distance traveled is the absolute value of that. It's positive 6. You traveled 6, but your displacement is negative 6. Displacement is also kind of like a vector quantity. So in this example, our overall displacement is positive 4, because we end up 4 to the right of where we started. Our distance traveled, though, is 16. Distance traveled tends to be much larger than displacement. However, there is a scenario in which your displacement and your distance traveled will be exactly equal. The only way that that can happen is if v of t is greater than 0 for all t on the interval. If that's the case, then your displacement and your distance traveled will always be the same. But that's actually the only case. If v of t is less than 0 the entire time, then your displacement is the absolute value. No, your distance traveled, sorry, is the absolute value of your displacement. But those are the only two scenarios. If you have any changes, then it's not going to work out. And we're going to do a lot of problems with this to help to clarify this. In general, distance traveled is a giant pain in the neck to find. Displacement is super straightforward to find, which is one of the easier ways of remembering it. So I'll be back in the next video, and we will keep going. So hope you're finding this helpful, and I will hopefully see you there.